Say it again. Mm-hmm. So when you make your chart, you need to go back over it. Go find those notes. But it's A times C goes here. So A was 1, C was 1. And then the B value is the negative 2. This is the chart. This is how you make it every single time. Okay. This one, no GCF. It can't be a chart problem. It's only got 2 terms. This is a difference of 2 squares. Difference of squares. 2 parentheses, 2 different signs. Square root of the first term is n. Square root of the last term is 5. That's how you factor. That's it. That's all you do. Then you set your factors equal to 0 and solve. So I would get n equals negative 5 and n equals 5. So 5 and negative 5, any order, those are the solutions to that quadratic. Okay? So chart problem with the shorter one. I'll do a longer one later. Difference of 2 squares. Okay? We'll cover all 4 types of factoring in this full assignment. So I'll remind you when we get to the other ones. Okay? All right. Now we're going into quadratic formula. You probably wrote it on your test, but if you want to like quiz yourself, maybe turn it over on the back and see if you can remember it. And then, because this is extra credit tomorrow, why not get all the points you can get? So I'm going to write it without you seeing. If you want to test yourself real quick, maybe turn your test over, your review over and write it. See if you know it. And I'm going to be strict about it. It has to be exactly like all the signs in the right places, all of that. So x equals negative b, there's a plus or minus, big radical going over the whole thing, b squared minus 4ac. And then all over 2a, not the radical over 2a, the whole thing, the whole numerator over the 2a. Okay, this is quadratic formula. This will be on the test for you, but this will also be what you could fill in right here to get your extra credit before the test. Okay? All right, so let's identify a, b, and c. So a is the number in front of your variable that's squared. Don't let it confuse you that that's an a. So a is 7. B is the number that has an x next to it. So remember, this is standard form. That's how I know the b value is missing, because we don't have just a plain a. It's missing. So b is your 0. And then c is your constant, the number that doesn't have a letter, and that would be negative 18. Okay? And then I'm going to plug in. Now, one of the things we talked about yesterday is when I made the review, I didn't hit a certain button on my test generator that made the numbers a little bit smaller. These numbers were pretty big. I made sure on the test the numbers were smaller and more manageable, okay? So it's good practice. If you can do the harder ones, then of course you'll be able to do this easier one. So x equals negative b. Guys, 0 is neither positive or negative. So I'm really not going to make it a negative. Plus or minus, they make a big radical. And I like to leave a little space above it. B squared minus 4ac all over 2a. Okay? So when I grade your test, guys, I like dig through it all. And I try to find any single place I can give you guys points. Being able to plug it in correctly, even if you mess the rest of it up, that's going to get you some points, because that's important to know, all right? That's good. You mess up after this, it doesn't mean you don't know anything, okay? So you make a mistake, you still get some points. All right, then we go to the radical. I see a lot of people on their phones and stuff. I am making a mental note to see what their test grades are. It's interesting to me. Some people that get Fs in here are still on their phones. 0 squared is 0, and then I type in my calculator exactly what I see there. Guys, I've done it so many times with you. I type in that every single time, starting with a negative 4. Negative 4 times 7 times negative 18. Okay? And I hit enter. That's a positive 504. Don't put minus 504. I already used the minus, right? It's already in there. And when I multiplied that in there, it ended up with a positive number. That means this is positive 504. Okay? That gets me to 0 plus or minus 0 plus 504 is 504 over 14. Now this is where I'm saying the numbers are not going to be this big. Okay? I'm not going to give you that big of a number. If you do get a big number, though, ever in a problem like this, I would first check it to see if it's a perfect square. So if I do this, the square root of 504, sometimes we get lucky and it's a perfect square. Is this one a perfect square? No. How do we know? What about this answer tells me it's not a perfect square? It's a decimal, right? It's not a whole number. So, okay, it's not a decimal. It's not a perfect square. So I have to, hypothetically, go through different numbers and find numbers that go into this that are perfect squares. Now, 4 goes into 504, but 504 is such a big number, I might try to find 504 is such a big number and 4 is such a small number, and this is a big number, I might try to find a even bigger number that goes into it. Like I'm going to jump to like 36. Oh, I didn't even mean to do it that quickly, but I did. Okay, but trying a bigger number, that way I don't have to simplify the 126 again. Okay, so sometimes a number has more than one factor that is a perfect square. This is why I'm giving you a smaller number on the test, not something so big, okay? But in this case, we're going to use 36 and 14, okay? 504, like, let me just go off to the side. I'm going to use this space. I'll go somewhere else to do this problem. But the square root of 504 is the square root of 36 times the square root of 14, right? That's what it equals. The 36 is going to become 6, okay? So I'm going to keep going over here. So I have 0 plus or minus, the square root of 36 is 6, square roots of 14 stuck inside, over, don't forget that 2 times 7, or 14 right there. Okay, so be careful, right here, you can't cancel these 14s. That's not a real 14 in the numerator. It's the square root of 14, okay? The square root of 14 is 3.74. So that's what that is. So we don't touch that. But you can simplify the numbers out in front. If we do 0 plus or 0 minus, we don't really even need the 0. If you left it there, I wouldn't mark it wrong, but it's not necessary. We don't really need that 0 anymore. But you can simplify 6 over 14. And if you didn't know how, 6 divided by 14, math, enter, enter, is 3/7. That 14 is still in there, and don't forget there's a plus or minus in front. We should always get 2 solutions, right? 2 solutions. And that positive 3 square roots of 14 over 7, negative 3 square roots of 14 over 7. And again, if you left the 0 in front, I wouldn't mark it wrong. If you wrote 0 plus or minus the square root of the rest of it. Okay? So simplifying the radical is the hardest part. Whatever number you get there, see if it's a perfect square. Yay if it is. If it's not, find a factor that goes into it. And like I said, I'm going to make that number smaller tomorrow. Okay? All right, let me do number 4 down here. 11a squared minus 2a minus 11 equals 0. Remember, it has to be in standard form. We have to have everybody on one side together before we can identify a, b, and c. Okay? All right, a, b, c, nothing missing. X equals negative b. Now, when I put a negative 2 in with a negative, they cancel out. So we can skip that part. Don't forget, when you square a negative, you are going to get a positive for AC all over 2A. So I'm still seeing you guys put that in your calculator without parentheses. Why even put it in your calculator? It's 2 times 2, or negative 2 times negative 2. That's 4. And then you pick up your calculator and you type in exactly what you see there. Negative 4 times 11 times negative 11. Again, I get a positive number. So I write plus 484. If I had a negative number there, which can happen, I'll get a negative answer sometimes, then I would write minus. So 484 plus 4. Again, a really big number. I apologize, it won't be that big tomorrow. Okay, so I have 2 plus or minus. Remember, I wrote up here, but it's still underneath the radical, 488. So let's check it to see if it's a perfect square. No luck. Okay, And then we want to try different numbers. Now, I tend to always start with 4, which is not a smart thing to do, especially with such a big number. It does go into it, so I know I found 1, but let's see if there's something bigger. Let's try 16. Now, let's try 9. Now, let's try 36. Did I try that? I don't know. Oops, 488 divided by 36. And then I go, wait a second. Divided by 4, that gave me 122. Is 122 simplifiable again? Does like 4 go into 122? Does 9 go into it? What I'm doing here is going back to my original answer, which was 4 and 122, and realizing it's fine. 4 is the biggest number that goes into 488. That is a perfect square. 122 can't be simplified any further. It feels like it should be able to, but it can't be. Okay? Yep. Oh, is it a plus? Okay. All right. Thank you for catching that. All that's going to change so far, it's not going to change anything I've done so far. Thank you, Mariana. That was a plus. That's going to make this negative. It made this a plus, but it doesn't change that. So be careful. I just recopied it wrong. Thank you, thank you, thank you. Okay, so back to that b, when I plug that in, x equals negative b, so that would be negative there, okay? And then whether you square a positive 2 or square a negative 2, you still get 4. Okay, so that part doesn't matter. Something. Okay, so that makes this a negative. All right, sorry about that. Thank you. All right, so 488, as we just said, is the square root of 4 times the square root of 122, right? So the 4 becomes a 2. Okay, so we get negative 2 plus or minus 2 square roots of 122 over 22. All right, we just verified that 122 can't be simplified anymore. You can try it. You can keep dividing it by 4, by 9, 16, 25, 36, all your perfect squares. It's not going to happen. That's done. Then the last step is to say, can I simplify these numbers out front? And I can. They're all just divisible by 2, right? So if I divide negative 2 by 2, I get negative 1. I divide 2 by 2, I get 1. So I don't really need to put a 1 in front of the square root of 122. If I do, it's okay, but it's not necessary. Okay? And then I divide 22 by 2, I get 11. So that's 2 solutions, guys. It's a plus and a minus. So, you know, my key always writes them out as 2 separate answers. If you remember from yesterday? That's the same thing as writing it as negative 1 plus or minus. It's the same thing. You can do it either way. These mean the same thing. It's just like I call it the lazy way of writing it. Writing it once with a plus and a minus in between. So either way. Okay? Right. So that is from section 3.6. So if you need to go back and quadratic formulas, if you need to go back over any of the quadratic formula stuff, that's in 3.6. Same with the discriminant is 3.6. Remember, the discriminant is just one little teeny tiny piece of the quadratic formula. The discriminant is the b squared minus 4ac. Do I take the square root of it? No. I just do this part of quadratic formula. Okay? So let's see what we get for this first one, and we'll talk about the different possibilities of answers. So again, I need A, B, and C. A is, oh, wait a second, be careful. This needs to be a 0. That has to be a 0. So when I bring it over to the other side, it cancels out. So I really have 10n squared minus 10n equals 0. I don't have a which letter. Which letter am I missing in my standard form? ax squared plus bx. I'm missing the c value. Do you guys get that? Depending on what, so look at the difference. If I have 4x squared minus 7 and 4x squared minus 7x, okay? This is A, right? What is this letter? C. How do you know? It doesn't have a letter next to it. This one is B because it has a letter. Okay, that's how you know. X squared is your A term, X to the first is your B term, and the constant, your C, is the number that has no letter. Okay, so we're missing C. So we have A is 10, B is negative 10, C is 0. And we just plug into the discriminant. B squared minus 4 times A times C. When you square a negative, you always get a positive. And then negative 4 times 10 times 0. Once they throw that 0 in there, it's just going to be plus 0. So our discriminant is 100. You don't do the square root. That is the discriminant. That's a point or whatever. 2 points just for getting the answer. That's the discriminant, 100. Then you say, is that going to be 2 real, 1 real, or 2 imaginary? 2 real. If it's negative, it's imaginary. If it's 0, it's 1. This is 2 real solutions. Think about why, guys. If you kept going with the whole quadratic formula, you do the square root of 100, you get plus or minus 10. You get 2 solutions out of that, okay? When you do the square root of 0, you just get 0. You don't get 2 solutions. You just get 1. And then if it's negative, you'll get 2, but it'll have an I next to it, so it'll be imaginary. It should make sense if you remember what we did before. Okay? Let's do another one. Again, you have to make sure there's a 0 here, so don't let that trick you. So that would be negative 3x squared minus 8x minus 5. So there's my A, B, and C. Plug it into B squared minus 4 times A times C. Anything squared is positive. 8 times 8 is 64. And write in my calculator, guys, negative 4 times negative 3 times negative 5. Right in my calculator, I get minus 60, which is 4. This is my discriminant. The discriminant is 4. And this is another 2 real solutions. Okay, so let's just go over the other 2 types in case they're on the test. Remember, if my discriminant is, I'm abbreviating badly, is 0, or if it's a negative 4, okay? This would be 1 real solution, and this would be 2 imaginary. So it's only those 3 options, okay? And then again, if it's a positive 4, it's 2 real. Those are the only options you can get. 0, positive, or a negative. Okay? All right, let's switch gears. We should be getting pretty good at the graphing at this point, especially if you know how to use your calculator. Right? This is vertex form. It's in vertex form. How do you know? It's got the parentheses. Remember, you pull out the H and the K. This is section 3.7 if you need to go back. So remember, H is always opposite. So it's negative 2, then the K is not opposite. So we've got our vertex. Our axis of symmetry is just that X value, right? It's always that. And we can go right to our calculator to get the chart. So clear your RAM. Pre-calc kids have been doing crazy stuff. And then type it in. Now, here, big common mistake I kept seeing yesterday is people using negatives and minuses accidentally. Be really careful. When you're confused, like is it a negative or is it minus, read it to yourself, not out loud. But if you read that, I don't think you'd say minus 3. I think you would say negative 3. So if I read this, I'd say negative 3 times x plus 2 squared minus 2. That's a negative, that's a minus. And we saw yesterday, right, Dylan, it made a difference if you got those confused, right? So negative 3 parentheses x plus 2 quantities squared. Bring that cursor back down, minus 2. Remember to get it typed in, and you can graph it if you want, but there's really no reason to. We really want the table. And we want to go to where our vertex is. So right now it's at 0, so I need to go where negative 2 is. And there it is, negative 2, negative 2. And then remember, you can pick two numbers, either before it or after it. I just picked these. And guys, if you do it right, your graph should match your numbers. Like, it shouldn't be, and that's another reason. Sorry, Dylan, just using you. Dylan had used the negatives and minuses accidentally, and his numbers, he knew immediately before he even started graphing something was wrong because his graph, the points that he had in his table were up here, and his graph didn't provide that space for him, so he knew something was wrong. So this test generator makes your coordinate plane match what your point should be. So if they're not matching, something's wrong. There's a good sign. All right? So that's left 1, down 5. Oh, sorry, let me do my vertex first. Negative 2, negative 2, so that would be right here. Right? There's my vertex. And then left 1, down 5. What's that one? 0, negative 14. We have that axis of symmetry going right through x equals negative 2 and reflect over that. Okay. It should be dotted. If you accidentally made it solid, like I almost started to, just write me a little note. Remember, if it's a greater than or a less than sign, it's dotted. If it's got the equal to sign under it, we would make it solid. And then it's greater than. Y is greater than. So greater than is either going to be on the outside of it or inside. On the outside. You have to think. So here's a good way. I was trying to find like a good way of explaining it, because some people just see it and some people don't. It's not dumb and smart. It's just how we learn. And I'm a very visual person. So find your vertex. If it's greater than, you want to shade above that. So above greater than this would be up here, which then tells me it's all on the outside. If it had been less than, that would be below the vertex. So that would have gotten inside here. So just nothing perfect. That's good enough. You can't see it. Okay, just showing that it's on the outside. Almost there, guys. This is exactly your test. So for those of you that are paying attention and taking good notes and fixing your mistakes, should do really well tomorrow. All right, one more of these. Why they give you 2? Because this one's standard form. This is not vertex form. You can't just pull the vertex out. You have to remember that little baby formula. Like for this one? No. Do you guys remember the formula? X equals negative b over 2a. Okay, so if you need to study that, study that. You need to know that formula for this. Okay. Is there a way around it? Could you work backwards? Yes, I'll show you how in a second. All right, so b is 12, so that's negative 12 over 2 times a. Sorry, 3. Okay, so when I go to, so let me show you how you could kind of work backwards on this to try and help yourself. Negative 2, let me just erase it. Negative 2x squared plus 12x minus 15. When I graph it, so I normally don't even tell you to bother with the graph, I can see where the vertex is pretty closely. Plus, if I go to the table, I can find the vertex by looking at the point. Can't you tell what the vertex is just by looking at these points? It's 3, 3. Because then on either side, the points are exactly the same. So maybe that would help you find your mistake if you forgot the formula here, but that's how I would do it. Okay, but I still want the table. Oh, I have the table. The table would be any two numbers, right, either side, maybe 4 and 5 would be fine. That'd be 1 and negative 5. axis of symmetry, x equals, don't just put the number, always this number. Okay, so my vertex, 3, 3, like I said, it should fit nicely on the graph provided. It shouldn't be like up in quadrant 2 way up here or something. It should fit if you did it right. All right, 4, 1, 5, -5, I can't see. Right? My axis of symmetry helps me get the other side. This is going to be a solid graph because of the equal to sign. Less than, okay? Below this vertex. Less than the vertex would be inside. If it was greater than, it'd be on the outside. Okay? And the last ones, this is our last opportunity to practice some factoring again. Substitution. And they're going to look just like this. Y equals Y, so what's on the other side equals each other. So you set them equal to each other. And then bring everybody over to one side. You want the x squared term to be positive. So we're going to leave x squared there and move these over. Yep. I don't know why it does that. It spazzes out on me sometimes. Okay, so y equals y, so that equals that. So I just set them equal to each other. And then I'm bringing these two guys over to the other side, so I get a 0 over here. Okay. So if they had like terms to subtract or add with, we did that. And we did. 3x minus x, our b term is gone. And we have just minus 2 left here. We haven't seen these problems as much. We've done a few of them, but they have been kind of rare, so I know a few of you were confused about this problem. This is not a difference of squares, because that's not a perfect square. If that was like a 4, you could do x plus 2, x minus 2, if it was a 9 or 16. But we can do this just by solving an equation. Add 2 to the other side, and then square root. And when you do the square root, don't forget, you always get a plus or a minus. Because remember, we should be getting 2 solutions here, unless it's 0, and you don't get a plus and a minus at 0. So any other number, you're going to get 2 solutions. So plus or minus the square root of 2. Now remember, that just gives us the x value. Okay, we need to get an ordered pair. And since it's a radical, we're going to have to change it to a decimal. Okay, how do you change it to a decimal? Just do the square root of 2 and round it. Like 2 places is fine. 1.41 and negative 1.41. So that's what that is. Approximately. Let's put it in my calculator. So those are my x values. One's positive, one's negative. Now I need y. I can plug these values into either one of these. Of course, this one's a lot easier. We don't have to square and all that stuff. So I'm just going to plug 1.41 in here and negative 1.41 in there. And I'll do it with a negative. And I'm just going to do it in my calculator. And that'll give me my 2y values. So 3 times 1.41 plus 7 is 11.23. And 3 times negative 1.41. I think. Okay, 3 times negative 1.41 plus 7 is 2.77. Okay, so don't let the fact that it's a radical bother you. Change it to a decimal and just plug in like you would any other x value. Okay. And the last one, oh, we didn't get to, okay. 3x squared minus 4x plus 2 equals 2 minus 2x. This will get one type of factoring, but I should go over the long method with you guys because I think there is a long one on the test, so I will. All right, so I need to make this a 0. So we do the opposite. Now we're crossing, so 2 minus 2, negative 2x plus 2x. So subtract 2 from there, add 2x there. So I get 3x squared minus 2x, and that cancels. This is one of our factoring methods that we're supposed to know. It's not a chart problem because it doesn't have 3 terms. It's not a difference of squares. There's hardly any perfect squares there. It's GCF. What do they both have in common? One is true, but also X, right? Chick-fil-A, the money. Okay, so since there's an X, I don't need to write the 1. You could, it's not wrong. Remember, you're just dividing. It's factored. Now you set your factors equal to 0 and solve. It's exactly what we did way back here. We factored and set them equal to 0 and solve. Factors are x and 3x minus 2. Remember, you get solutions from your x's, just not in real life. You set each of your factors equal to 0. And you'll get a solution out of this one and out of this one. That one's already done. X equals 0. 0 is a number. You can get an answer of 0. That's fine. And then add 2, divide by 3. So those are my 2 x values. Remember with these, though, it's a pain. That's not our final answer. Remember, the solution to a system is an ordered pair. And in these, it's 2 ordered pairs. So this just, when you solve these systems, just like we did here, we get 2 x values. Then we still have to plug in to get our y values. Lots of stuff on this test. This is not an easy test. I'm going to plug into this one. Y equals 2 minus 2 times 0. I'm going to do that in my calculator. And y equals 2 minus 2 times 2/3. Right in my calculator. Plug in 0, plug in the 2/3. 2 minus 2 times 0. 2 minus 0, we're going to get 2. And guys, just be careful with your order of operations here. Let me see if it even works. 2 minus 2, parentheses, 2/3. Yeah. And you should get 2/3 again. Remember, math enter, enter. Changes your decimal back to a fraction. That would be your solution. There's a lot to know for this test. Now, I do want to, for any of you that need it, I'm going to do one last thing. Is I want to do the long type of factoring, a practice problem, because there is one on the test. So it's like this one, just like this, but with a number in front of the n squared. Okay? So if you are someone that doesn't do, and it's very common to not do well on that. That's one of the things that a lot of students mess up on is that type of factoring. So just, you don't even have to write it down if you don't want to, but I would just pay attention. Let me just find one. Here it is. Yeah, B2. Back at the beginning of the quarter, I did a whole factoring review worksheet with you guys. And there's a video. So B2 video, if you need help with any of the factoring, that would be a good one to watch. Okay, let me find a good one. Okay, so here's a review of how to do the long factoring. Okay, so a problem like this could totally be on the test. First thing you want to look for is there a GCF? Are they all like divisible by 2? No. Okay. Next thing I go, oh, this is a chart problem. How do I know? Quadratic, 1, 2, 3, trinomial. Has to look like that. That's how I know it's a chart. Zeros over here, that's good. A, B, C. And you don't have to label the whole chart. Like this is just like my workspace. I'm just showing you what I'm doing and writing it all out. Okay, so A times C, that's 2 times negative 63. 2 times, is that the number in that triple? Yeah. 2 times negative 63 is negative 126. And B is negative 11. This is a bigger number, but it's not like in the 400s, 500s. This is a valid problem you can see, okay? I don't know, like if this was 12, I don't need a calculator. I know what numbers multiply to get 12. But I, who am good at factoring, still need to pick up my calculator at times to find numbers that go into 126. I don't have that memorized, right? So, and don't worry about the signs. Just start looking at numbers. Like, I know it's divisible by 2, but 2 and 63 is, there's no way to make an 11 out of that. So I just kind of play with it. And what's nice about these calculators is you can see some of the numbers that you tried already. Okay, 2 didn't work, 3 didn't work. Let's try 4. Yeah, I know 5 won't go into it. How about 6? Ooh, 6 and 21. Does that make 11? No, right? 21 minus 6 is not 11. But I'm getting closer. And literally, sometimes it takes people this long. People like me, okay? I'm not acting here. I really didn't know what the two numbers were, okay? So it took me a little while, but it's not impossible, especially with a calculator. I find my two numbers. Oops. And then I have to play with the signs. I need to get a negative 11. That will make the 18 negative. Try it in your calculator if you don't believe me. And then try it over here. Make sure it works in both places. And it does. Okay? So this is usually the hardest part. How do I get my numbers and my signs right? Okay? Because of the 2 here, I have to do the long factoring. 2x squared comes down, and then negative 63 comes down. And then you split the middle into these two numbers. Technically, it doesn't matter which one goes first, but if you have a choice, if one of them is negative, I always like to put the negative first. And don't forget to give them both an x. Guys, what I just wrote here should equal this exactly. And it does. Negative 18x plus 7x is negative 11x. So that's a good check right there. Am I good so far? Yes. Then you do your 2 and 2. GCF of the front 2. Oh, 2 goes into both of them, and Chick-fil-A, they each have $1. 2x. You don't even have to show this. You can do it in your head, but I'm showing you what I do. When I divide 2x squared by 2x, I'm left with x. And there would be a minus. 18 divided by 2 is 9, and those x's cancel. Now listen, the other set of parentheses should end up being this. Right? Remember, that's something that's helped. If you're really stuck at this step, you should know it's going to be x minus 9. You could almost work backwards. But these two have a 7 in common. So if I divide that by 7, I get x. If I divide that by 7, I get 9. That makes us so happy when it works out like that. Our answer, the parentheses, twins, identical twins, either parentheses. It doesn't matter which one you put it in. And then your GCFs. That's how you factor those. We have to know how. And then, of course, if it was on the test, you'd have to solve it too. That's set each of your factors equal to 0 and solve. So this one's 9. Easy peasy. Subtract 7. Divide by 2. And there's so many different ways you could write that. Negative 7 has negative 3.5, negative 3.5. Any of those would be fine. And 9. Okay? So don't forget how to do the long factoring. When do you have to do it? When there's a number in front. Why didn't we do it on the very first problem? Because there was a 1 in front. That's why. We could skip that step. We went right to our answer. So notice the difference. Big, big, big important stuff. How are we going to do in the test?